I decided to do a special project for Pi Day. I used VoiceAttack to make a program which would draw out the Sierpinski Triangle in Microsoft Paint using a basic set of mathematical rules, that you mark your current point, randomly pick a corner, move halfway to that corner, and repeat. This is not the Sierpinski Triangle. But I also wanted the option of changing the number of corners involved, and using other fractions than 1/2 for how far to move to a corner, and see how this changed the resulting diagram. To most people, this would have been surprisingly difficult. For users of VoiceAttack, it was unsurprisingly difficult, because VoiceAttack is not at all designed for this sort of thing. Decimals and integers cannot mix. You can't even take a decimal and multiply it by an integer, or even add on the integer. And whenever you've done that wrong, it doesn't tell you. It can't store arrays, so every potential corner has to be a specifically declared variable. And every individual mathematical operation needs to be on a separate line. This means that if you have a complicated formula, you need to think about how you can do it one step at a time, or break it down into assembling multiple variables and adding them to each other. And I did almost all of this using only voice recognition, with VoiceFinger attached to Windows Speech Recognition. I'm not sure I'll release a video of this anytime soon because it took about 6 hours, including 20 minutes of cheating by debugging manually. Nevertheless, it works. Let's check it out. Initialize variables. 3 corners. By default, the distance to move to a corner is 1/2. Begin computation. Now when running this, I found the bottleneck was actually how long it clicked with the left mouse button. By default, it's 0.1 seconds. I have found I can increase that a bit, but I'm hesitant to go too far in case the computer complains and the recording doesn't work. So now it's only 10 milliseconds per click, and so an upper limit of 100 dots per second. Although I think it's certainly less than that because it has to do all its computation and it's not a mathematically optimized program because, you know, it wasn't designed for this. But I like that it can do it. Reset canvas. Let's do something else. 4 corners. Set numerator to 2. Set denominator to 3. Begin computation. Stop. So if we assume that it's a given denominator and 1 less that on top, and the denominator is 1 less than the number of sides, then we could try 3/4 and a pentagon. Reset canvas. 5 sides. Set numerator to 3. Set denominator to 4. Begin computation. One advantage that my system has over most people's way of doing this is that I can change the numerator and denominator at any time. Set numerator to 1. Set denominator to 6. Stop. Initialize variables. 8 corners. You'll notice they're not perfectly arranged to make a regular octagon. I decided I wanted a little tweak on each of these, which turned out to add at least an hour to the construction time. But I'm still glad I did it. Set numerator to 6. Set denominator to 7. Begin computation. So that makes another nice fractal. Now when we did 5, I used the fraction 3/4, so that it might be worth exploring what 1/4 and 2/4 do. Or even going back to the triangle, 3 corners. Set numerator to 1, set denominator to 4. Begin computation. Unfortunately, it might take a while to figure out if this is just a random spattering of dots, or if it actually has some structure. Yeah, that looks pretty random. 5 corners. Begin computation. So this is 5 corners with 1/2 instead of 3/4. It might also prove to be a mess. It's possible there's a very fuzzy structure here, because there's a gap in the middle, but I think it just means that it's less likely to land in the middle, and then there are sort of, well, 4 of the 5 pockets towards the corners around that seem to exist, but I think those would get filled in as well. 6 corners. I also want to try a half with this. Begin computation. Given these sort of chaotic messes I'm making, I probably should have looked up ideal values. Six sides. Set denominator to 5. Begin computation. Reset canvas. 6 corners. Set numerator to 4. Set denominator to 5. Begin computation. I think I'll leave it there. A snowflake of snowflakes. But yeah, worthy challenge, and glad I got it done in time.